Hello friends, this is chapter number 2, energy of orbital, and here lecture number 10 is there. So now we will discuss energy of orbital in case of chapter number 2. So you have to remember one thing, the energy of electron in hydrogen atom is determined solely by principal quantum number. Again I am repeating same statement, energy of electron in a hydrogen atom is determined solely by the principal quantum number, which is represented with the help of small n. So whenever we are writing orbital on the basis of sequence of cell, this is K cell, this one is L cell, this one is M cell, then after N cell will come. In case of K cell, 1s will come. In case of L cell, 2s and 2p is there. In case of M cell, 3s, 3p, 3d is there. While in case of N cell, 4s, 4p, 4d and 4f will be there. So see, in case of K cell, only one s orbital is there. But in case of L cell, 2s and 2p. Here s and p are member of L cell. Therefore, energy of s and p will remain same. Same condition will come in case of M cell. In case of M cell, here 3 orbitals are there. Why 3 orbitals? Because principal quantum number for M cell will be 3. Here 3s, 3p, 3d. The energy of 3s, 3p and 3d will remain same. Same condition will come here also. Clear? Now next one, the shape of 2s and 2p orbitals are different. Shape of here energy will remain same, but shapes are different because shape is related with respect to angular quantum number. Now shape of 2s and 2p orbitals are different. An electron has the same energy when it is in 2s orbital as when it is present in 2p orbital. तो मैंने आपको पहले ही बता दिया कि if your electron is related with respect to S as well as P, their energy will remain same. Now, the orbital having the same energy are called degenerate. So this is definition of degenerate orbital. What is degenerate? See, the orbital having the same energy are known as degenerate. Here S and P, SPD, they are example of degenerate orbital. Now next one, for hydrogen atom. Why we are selecting hydrogen atom? Because in modern periodic table, hydrogen is first element. So whatever thing we will discuss, it is always applied first of all on hydrogen. In case of hydrogen atom, here 1s, 2s and 2p. So 1s is situated in ground state and 2s and 2p is situated on excited state. It means if we are writing orbital, then orbital which is present bottom side, it is normally known as ground state. An orbital which is present above this ground state, it is normally known as excited state. So here orbitals are further divided into 2 parts. One we can say that ground and second one is excited. Clear? Now next one, here energy of electron. The most important point is energy. The energy of electron is always related with respect to principal quantum number and angular quantum number for multi-electron system. Clear? Again I am repeating, the energy of electron in a multi-electron atom depends upon N as well as we can say that L. So what is multi-electron atom? Where number of electron will be more than 1. This is mono, hydrogen is mono and this one is multi. You have to remember one thing. Energy is always related with respect to principal quantum number as well as angular quantum number. Now next one, that is for a given principal quantum number. Here S, P, DF orbitals are there. So all have different energy which is due to mutual repulsion among the electron. It means if principal quantum number value will changes, then arrangement of orbital will also change. For example, here principal quantum number is 1, therefore only 1s orbital will come. Here 2, so 2s and 2p will be there. Similarly 3, so 3s, 3p and 3d is there. Similarly 4s, 4p, 4d and 4f will be there. Clear? Now in case of multi-electron system, in one orbital 2 electrons are there. So whenever these 2 electrons are present, then here either attraction will take place or repulsion. So attraction and repulsion both are related with respect to direction of spin. If both direction of spins are in same direction, either in upward or downward, so repulsion will take place. But whenever it is in opposite direction, then here we can say that repulsion will never take place. So now next one, stability of an electron in multi-electron atom is because total attractive interaction are more than the repulsive interaction. Clear? In which condition stability will be there? जैसे देखो अभी हाइड्रोजन है ना, यदि मैं 2 हाइड्रोजन एटम को हम लोग पास में लेके आते हैं, here repulsion will take place. Why repulsion? Because 2 hydrogen atoms are same. So whenever we are taking 2 hydrogen atom close to each other, here some repulsive forces are there. अब आपको तो बॉन्ड बनाना है, तो क्या करना पड़ेगा? Whatever amount of repulsive forces are generated here, whatever amount of repulsive forces are generated here, उससे ज़्यादा आपको applied amount of attractive force लगाना पड़ेगा. Then after 2 hydrogen atom will join with each other, and then in that condition your unstable hydrogen atom will become stable. So this is one of the most important line. Clear? Now next one, the attractive interaction of an electron increases with increase of positive charge on the nucleus. Again I am repeating. The attractive interaction of an electron increases with increase of positive charge on the nucleus. इसी को आप ऐसे बोल सकते हो. See, जैसे यहाँ पे मैं आपको बोलूँ, this is sodium plus 1, this one is magnesium plus 2 and aluminium plus 3. Then with respect to electron, here sodium, magnesium and aluminium, they are same because here 10 electrons are there. But with respect to nuclear attraction, here aluminium, here attraction or attractive force in case of aluminium will be more. Why? Because charge is plus 3. वही यहाँ पे लिखा है. The attractive interaction of an electron increases with increase of positive charge. इधर देखो plus 1 है, इधर plus 2 है, इधर plus 3 is there. Clear? Now next one, due to the presence of electron in inner cell, actually 2 different type of cells are there. One is inner and second one is outer. जैसे ये मैं lithium का लिखूं, तो lithium मतलब 1s2, 2s1. So this is inner cell and this one is outer cell is there. Clear? Now, so due to presence of electron in the inner cell, the electron in the outer cell will not experience the full positive charge on the nucleus. अभी जैसे lithium है तो 1s2 है, 2s1 है, तो due to presence of this 1s2 electron, 2s1 का जो nuclear attraction है, it will be not that much effective. Clear? Now here due to the presence of electron in inner cell, the electron in outer cell will not experience the full positive charge on the nucleus, but will be lower due to the partial screening of positive charge on the nucleus. Again I am repeating. Partial means it is not fixed, it is variable. Again I am repeating. Due to the presence of electron in the inner cell, the electron in outer cell will not experience the full positive charge on nucleus, but will be lower due to the partial screening of positive charge on the nucleus. In another way, we can say that This last point is known as shielding effect. So what is shielding? Shielding means layer formation. Shielding is nothing but it is normally known as layer formation. In case of energy of orbital, last point is again shielding. So what is shielding? Shielding is nothing but it is normally known as layer. And we generally in our life we know very well layer formation. Layer is nothing but it is normally known as shielding. In the field of chemistry, another name of layer is normally known as shielding. The shielding of out cell electrons from the nucleus by the inner cell electron and net positive charge experienced by the electron from the nucleus is known as effective nuclear charge. This is second important definition. पहला क्या था? Degenerate orbital. Now again, the shielding of the out cell electron from the nucleus by the inner cell electron and net positive charge experienced by the electron from the nucleus is known as effective nuclear charge. For example, जैसे aluminium है, तो whenever aluminium will donate 3 electron, then what will happen? If aluminium will donate 3 electron, now after donation of 3 electron, now it will become aluminium plus 3. So now nature of simple aluminium and aluminium plus 3 is totally different. So that type of thing we can explain with the help of effective nuclear charge, represented with the help of capital Z, E double F and then after small e. Clear? It means see, whatever metal we are selecting, its nature is directly associated with respect to its valency. उसी को हम लोग बोलते हैं इफेक्टिव न्यूक्लियर चार्ज. क्लियर? अब इसी के ऊपर एक सिंपल लॉजिक आता है. If valency of any material will be more, if valency of any material will be more, then for any isoelectronic species, what will happen? If valency will be more, then nuclear attraction will be more, and if nuclear attraction will be more, then size will be less, and if size will be less, then stability will be more, and if stability will be more, तो solubility will be less. So this concept was given by Fazan, इसीलिए उसको बोलते हैं Fazan's rule. Clear? जैसे चल अभी सोडियम +1, मैग्नीशियम +2, एल्यूमिनियम +3, इसमें सबसे ज्यादा स्टेबल कौन होगा? एल्यूमिनियम +3. वाई? देखो सोडियम में 10 आया, मैग्नीशियम 10, एल्यूमिनियम 10. Whenever valency will come, मतलब Na+1, Mg+2, aluminium +3. So with respect to total electron, they are same. But here, due to effective nuclear charge, stability of aluminium +3 will be more. Therefore, solubility of aluminium +3 will be less. Now, energy, see, the energy of interaction between the nucleus and electron, and electron decreases with increase of Z. Z means atomic number. Again I am repeating. Energy of interaction between the nucleus and electron, मतलब nucleus and electron, it will decreases with the increase of atomic number. It means if number of cell will increases between nucleus and outermost cell, then here size will increases, and if size will increases, then nuclear attraction will decrease. Again I am repeating, if size will increases, in which condition size will increases? So whenever atomic number will increase, and atomic number is represented with the help of Z. Clear? मतलब in periodic table, if we are going above to below, then atomic number will increases. So here we can say that size will increase. But if we are going left to right, the atomic number will increases, but size will not increase here. Clear? Now next one, both the forces. Which type of force? यहाँ पे देखो word दिया है. Both the forces. तो which type of force? Attractive as well as repulsive. So both the forces depends upon the cell and shape of orbital. Clear? Both the forces. Which type of forces? तो attractive as well as repulsive. The attractive and repulsive forces depends upon cell and shape of orbital in which electron is present. Clear हुआ कि नहीं? तो whatever forces are there which is related with respect to nucleus and outermost electron, so that forces are only two, attractive as well as repulsive. So this type of forces depends upon cell as well as shape of orbital in which electron is present. For example, देखो, being spherical in shape, s orbital you know, spherical in nature. The s orbital is again we can say that spherical in nature. So being spherical in shape, s orbital shield the electron from the nucleus more effectively, here more effectively as compared to p orbital. Clear? Again I am repeating. Being spherical in shape, s orbital shield the electron from the nucleus more effectively as compared to p orbital. देखो s will shield more effectively electron related with p orbital. p shield more effectively electron related with respect to d orbital, and similarly f orbital will come. मतलब shielding of s and p यदि मैं कंपेयर करूं तो shielding of s will be more effective as compared to p orbital. अब यदि मैं p और d को कंपेयर करूं तो shielding of p orbital है ना, shielding of electron with respect to p orbital will be more as compared to d orbital. And similarly यदि मैं d and f को कंपेयर करूं तो shielding of d orbital will be more as compared to here means f, and similarly in case of f and g will come. मतलब shielding is directly related with respect to distance between nucleus and outermost cell. So this is one of the most important line. Clear? Now next one, suppose if you are interested to remove electron from K cell. Suppose if you are interested to remove electron from K cell, then you have to supply more amount of force because distance between nucleus and K cell will be minimum. Distance between nucleus and K cell related s orbital will be minimum. अब आप ऐसी suppose if you are interested to remove electron from 2s orbital, देखो 1s is close to nucleus, 2s is far away from nucleus, or in another way we can say that electron related with 2s orbital है ना, distance of 2s orbital is more as compared to 1s orbital. तो आपको इलेक्ट्रॉनिक कन्फिगरेशन आना चाहिए. नाउ नेक्स्ट वन, सी फॉर अ गिवन सेल, यदि आपको दिया हुआ है फॉर अ गिवन सेल द इफेक्टिव न्यूक्लियर चार्ज एक्सपीरियंस बाय द ऑर्बिटल डिक्रीजेस विथ इंक्रीज ऑफ एल. एल मतलब प्रिंसिपल क्वांटम नंबर, दैट इज s orbital will be more tightly bound to the nucleus as compared to p orbital, जो मैंने अभी आपको बताया. Clear? Here we can say that s orbital is close to nucleus, so whatever electrons are related with respect to s orbital, it is more tightly attached as compared to p orbital. Clear हुआ कि नहीं? न्यूक्लियस के क्लोज कौन है? s ऑर्बिटल. उसके बाद कौन है? p ऑर्बिटल. उसके बाद कौन है? d ऑर्बिटल. समझ में आया? अगेन आई एम रिपीटिंग. फॉर अ गिवन सेल द इफेक्टिव न्यूक्लियर चार्ज experienced by the orbital decreases with increase of L. L मतलब कैसा होता है? सी यदि मैं L की बात करूं तो L देखो, here L is equal to 0, 1, 2, 3. So this is S, P, D, and then after F will come. It means if L will increases, so nuclear attraction will decrease. L is nothing but it is angular quantum number. है ना? Now next one, the lower value, देखो, the lower value of n plus L for an orbital, the lower is energy. It means how we can find out energy of any orbital? The energy of any orbital can be determined with the help of n plus L rule. Energy of orbital can be determined with the help of n plus L rule. Clear or not? तो अब देखो n plus n is principal quantum number and L is angular quantum number. जैसे देखो अभी 4s in 3D है तो 4s में n plus L की वैल्यू क्या है? 4 और 3D में क्या है? 5. इसीलिए energy of 4s is less as compared to 3D. Therefore, whenever we are writing sequence of orbital, then 4s is written first of all, then after 3D will come. It means if we are writing orbital, then first of all 1s, then 2s, 2p, then 3s, 3p, and 4s will come. Then 3D is there. Clear? Why? Because we are following this type of rule, n plus L energy rule. But suppose if two orbital have same value of same value of n plus L आ गया, तब क्या करोगे? So here the orbital with lower value of n will have the lower energy. If n plus L value will remain same between two orbital, then what will happen? So first of all we will write down that orbital whose principal quantum number value, that is n, will be less. Now next one, energy of orbital. देखो, energy of orbital in the same subcell decrease with increase in effective nuclear charge. Clear हुआ? Again I am repeating. Energy of the orbital in the same subcell decrease with increase in effective nuclear charge. जैसे देखो अभी एनर्जी ऑफ 2s है, हाइड्रोजन है, ये सबसे ज्यादा है ना? फिर देखो लिथियम का 2s है, सोडियम का 2s है और ये पोटेशियम का है. तो हाइड्रोजन, s ऑर्बिटल ऑफ हाइड्रोजन इज क्लोज टू न्यूक्लियस. s orbital of hydrogen is close to nucleus. Therefore, we have to supply more amount of energy for separation of electron related with respect to s orbital. Clear? मतलब एनर्जी, पूरा टॉपिक क्या था? एनर्जी ऑफ ऑर्बिटल. तो फाइनली कंक्लूजन क्या आता है? इसी सपोज इफ यू आर इंटरेस्टेड टू रिमूव इलेक्ट्रॉन, है ना, फ्रॉम k cell, then you have to supply more amount of energy as compared to L cell. Clear? An energy of orbital can be determined with the help of n plus L rule. So this is complete information of energy of orbital. तो जितना मैंने आपको बोला है उतना अच्छी तरह से कर लेना.